Hello everybody and welcome back. In one of my last videos I talked about how my little CW-5000 industrial chiller was not performing as I would expect it to, and I had a few problems with that. And in the end it turned out that the seller whom I got this off as the cheapest CW-5000 on eBay doesn't have anymore. So we had a nice discussion and they gave me a very nice rebate on this unit, and I thought, let's go out and fix it. Since it's basically working, I think we have a good chance of resurrecting parts of it and maybe even making it a little bit better. And yeah, let's get to it. So I didn't know how to start out, so I got myself another thermostat and I thought I'd just have a look inside. And they're not really hard to take apart, which is cool. And basically I found common components. There's a display, there are some relays, there are connectors, there's some sort of power something in there, and yeah. So I set out to get myself the same components. I started out by getting a 7-segment display, and it didn't take me long to find out that I got a 7-segment display that didn't have any decimal points. So I will be forced to use full degrees, but that's okay for a start. I got myself some relay blocks and I got myself a microcontroller. And the first thing that I did was I kind of reverse engineered the way the existing controller worked and started building on that. And I came up with a very simple design of a cooler setup that would use 5 distinctive stages of doing its job. Where the first stage is pretty simple. The first stage is being idle. From the first stage, if the temperature drops, it will go into a stage called startup, where it starts the compressor and makes sure that everything runs, well, turns everything on. From there on, it goes into a stage called cooling, which, well, it does exactly what it's named after. After it started cooling, we hope that the water gets colder. And once the water has reached a threshold, it will go onto a stage 4, which is called holding. And in hold, it basically opens its bypass valve and leaves the compressor running just in case that there's load on there, and holding means that the temperature will rise right back up again, where it will go back into cooling. And once it's done holding and it's held on for long enough and the temperature is still dropping, it will go into a 5th stage, which is called cool down. And in cool down, the only thing that it really does is run the fan, because while it's been holding or cooling or starting, things inside the machine just warm up. So it's just fair to run the fan for another minute and have it bring down those temperatures. And once it's done with that, it goes back into idle. Now, there are some things that can happen. For example, if we are in holding and the temperature rises inside the water and we need to cool more, we can jump back to cooling. If we are in cool down mode and for some reason the temperature gets high really quickly because we've started dumping a lot of energy into the cooling water, it can basically jump right back to start. So these are relatively simple changes to a state machine, and they were very easy to code up. And within a few hours or so, I had this. This is basically a very, very simple prototype. It has something that somewhat resembles the original module, but everything is just made so it can be glued together with hot melt and it will stay in place. And if you think that this hole here is kind of weird, there's a reason for that, because I want to be able to program this thing while it is built into the chiller. So I can actually program the whole thing while it is inside the chiller. The relay block is kind of simple. It does have some drawbacks. This screw is really close to that terminal, and I'm going to have to put some insulation down here just to make sure that this can't touch anything. There is like a millimeter between the screw and the bottom of this, but I'm still going to put some insulation there. But this thing works. So if I set it up now, it's going to tell you error 1, which means there is no temperature probe attached, because the temperature probe that I have is not the one that's in the machine. I'm going to have to move the 2 probes that are in the machine over to this here. And I'm going to start doing this now, and I'm going to bring you back once I have something that is either working or broken. I hope it's working, I really do. So yeah, let's start tearing into the chiller. So first slight setback, I got the T503 out, and that wasn't an issue, but my new controller is too thick. I don't know why. I must have gotten the measurements wrong, because the other one I had is exactly the same size. This thing is 3 millimeters too high, and it won't fit. Yeah, I'm gonna have to 3D print another one. Shouldn't be too much of an issue, but it's gonna take time. Okay, next morning, and I've got a new tray for all of the electronics, and this one fits. In fact, I printed another one just like this yesterday evening, and although I had changed the height, it came out with the same height. And it turned out that somebody forgot to reset a Z-axis stretch on his slicer software. So this thing's also 10% higher than it should be, but it doesn't matter for that part. But yeah, that was just kind of stupid. Well, now I've got the correct part, and I managed to change one little detail, and you can see it right on the edge here. Since I don't have anything holding it in, I put a groove in the bottom that slots into the tin, and I put a little hump on the top, and this lets it slot in really tight. So I can just put 2 blobs of glue on the top here, and this thing should be held in pretty much permanently. I don't know if I'm going to change anything. I've noticed that I have I think it's an OLED display that should almost fit in here instead of this 7-segment. But for now, I'm just going to take all the parts that are in here and I'm going to move them over here. And once I'm done with that, yeah, let's try to put this one in. So I have everything mounted inside the chiller and everything's wired up. And we can just send it through a test now. It's connected to a laptop computer, and I can just power on the Arduino, and we can see what happens. It should go through a test. I've already tested that all of the temperature sensors and everything work out. And if I turn it on now, then it goes through initialization. And after that, it's going to go into a cooling cycle. As you can see, this is basically the original wiring. The only change to that is that there's now a dedicated wire for the fans, because I want to be able to run them after the cooling has stopped, because I noticed that the compressor was getting really warm. So was the solenoid for the bypass valve. And I just want to expel all of that heat out the back of the machine when I turn it off, because otherwise it's just going to start warming up the water that we've just put so much energy in for getting it cold. Yeah, so I know that all of the temperatures work. The code that I have on the Arduino just has very simple limits for maximum temperature of the ambient temperature and the water. So if it starts getting really hot in there, it's going to turn off and go into error mode, switch everything off. And same is true for the water. If it notices that it can't get the water any colder, that could be because there's no water in there, or because there is no, the cooling isn't working, then it will also switch off. But I haven't really tested that yet. I'm going to go through much more testing with that. The only other changes that I did was I removed the screws in the back of here because they were too close to the terminals, and for right now I just used a cable tie that's plastic that doesn't conduct electricity, so I hope this is a lot safer. Okay, so the next thing would be to power it on with the chiller and basically see what happens. The only thing that I'm not so sure about are the relays and the buck converter on the Arduino, but we'll just see that. So let's get you set up and let's turn it on. Okay, so first test, and I really hate first tests. Usually I would have a separator for the mains, but at 500 watts that doesn't work anymore, so let's be really careful here. Okay, we got power, and let's turn it on. Solenoid works, fan works. Wow, cool. And something is not working. Well, that wasn't too successful. I don't know what happened there. As soon as the compressor turned on, it seems like the temperature just shot down pretty quickly. Could be a problem with the supply voltage. So our input voltage is 24 volts. And that doesn't drop. But we're getting real weird temperature fluctuations here. Really weird. Secondary voltage is 5 volts. And the secondary voltage is absolutely rock stable. So what it's actually doing is it is switching back and forth between cooling and holding. Well, given the temperatures, that could be. So I think it's working. It's just working very strangely, to say the least. Let's connect up our data logger. That should help. Well, I'm still debugging this thing, but I've made some progress. It's just been through an entire cooling cycle, and it is actually reporting 15 degrees Celsius, which is odd because if I really measure this at the pipes, you can see that it's like 17.8. The water might be a little bit cooler than that because this is just on the outside, but it appears that the sensor in the tank is pretty far off. If we take a look at the curves that are recorded during the cooling, you can actually see that it warmed up to the hysteresis point over the set 16 degrees. Then it cooled down pretty quickly, and it stopped cooling right about at the hysteresis point below the 16 degrees, which is pretty much spot on where I want to have it. And now that it's cooled down, it is holding very well. And you can actually see that it went through all the stages of cooling. So stage 1 is idle, stage 2 is very short because it's just the motor startup. Cooling held for quite some time. Then it held with the solenoid open until it had coasted to the hysteresis point, and then it went into the cool down cycle where it's just running the fan. So this is pretty much exactly what I want to have. The thing that I have right now is I have a power supply issue. The 24 volt power supply in the chiller is running the pump, and the pump seems to be there's a lot of noise on that power supply. So if I have this running for too long, it is just going to either make the serial chip go haywire, so I can't log anymore, or it will cause a short reset of the Arduino, which of course I have to fix. But right now it actually looks like it's running pretty well, and I'm gonna wait for the next cooling cycle and I'm going to bring you back then. So I've let this thing warm up for a bit, and it's currently starting to cool down, and it will shortly reach the point where it should turn on and go through a cooling cycle. Right on time. And yeah, let's watch it. So unfortunately, same thing that happens a lot of times, the data logging is stopped. This mostly happens when the compressor turns on, but yeah, I don't know what I can do about that. Well, we can actually watch the cooler itself now. So now it's going into the hold mode, and it's just going to let the temperature from the coils and everything that is in the water also cool the water. And basically if there would be any load right now, it would be staying in hold mode for I think up to 60 seconds. And if the temperature creeps back up, it will go back into cooling. So now it's done holding, it's reached the lower hysteresis, and it's now only running the fan for another 60 seconds to cool the device, and then it's going to go back into idle. At least that's what I hope. Yeah, and unfortunately the data logging actually stopped. And yeah, the Arduino seems to run fine, but the serial chip just dies. Or maybe it's the serial the USB port on the laptop. Not sure about that. Now I've actually got the laser running, and I have it running on the internal power supply, so the new thermostat is completely running standalone. And as you can see, it went through a complete cycle of cooling while the laser was running. And you can also see that it took a lot longer before the thermostat left the hold mode, which is really cool. The laser is running at 40%, so it should be generating about 150 watts of thermal energy, which it's dumping into the air and into the water. And yeah, it seems like it's working really well. And we should be coming up on the next cooling cycle really soon. As you can see with the upper temperature, this sensor is actually not being denoised through software, so it's all over the place. And yeah. It seems I fixed some of my problems with the connection problems by just putting a big ferrite onto the data cable. That seems to have fixed some of it. Yeah, this is working really nicely. This is just the way I wanted it. The laser's been running for half an hour or so now, and the chiller is working absolutely perfect. The temperature curve that I'm getting on the output is within about 0.8 degrees Celsius, and I have a hysteresis of 0.8 to the positive and to the negative, and it's holding that absolutely perfect. And I've increased the laser power a little bit because I wanted to see if we ever get into the to the point where we need the hold to actually stay on for a long time, but that's basically not happening. So yeah, I would say that is working very well. In fact, the problem that I've been having at the beginning is basically fixed now, and I'm really happy with that. So yeah, it's really nice. And as you can see, it looks kind of quirky on the front of the laser, but actually it's quite a nice solution, because I can just put a USB cable in there and start measuring. From the back, it doesn't look that professional. So here's the Arduino, and there's my relay board. And yeah, it's simple but seems to work. And if you look at the temperature curve, it looks almost perfect. So I'm gonna fix the temperature curve for the internal sensor as well, and I suppose then I'm done. So thank you very much for watching, and bye bye. So a really quick update, because I did change a few things. I added another trip point, and that keeps a watch on the temperature inside the case. So if the pump is running and if the compressor's been running, the temperature is going to rise over time. So if the temperature inside the case rises, I don't know, about 4 degrees over the trip point of the water sensor, I can actually see the water sensor rising a lot quicker. So I added the trip point that will turn the fan on for 1 minute when it reaches a certain temperature, and this has actually led to a doubling of the time between the firing of the water trip sensor. So by running the fan, I don't know, like every 5 minutes for 1 minute, or I think it's more like every 7 or 8 minutes for 1 minute, I can make the time between when it needs to cool the water double, which is really neat. I wouldn't have thought that it made so much of a difference, but it really does. So the water temperature is staying rather well within the within its temperature window, and now it just tripped, so it's going to start the cooling cycle. But if I remove the energy that builds up inside of the case of the chiller, I can actually make the water stay cool for a lot longer than it did before. And that was a very simple code change, and it really made a lot of sense. And as you can see, we're getting really rapid drops every time that the fan turns on. So there is some heat storing inside of the case. Yeah. And now that it's starting to cool, it's going to cool down really quickly. It's going to hold for, I don't know, 30 to 40 seconds. And then it's going to go into the fan only mode, and the water temperature is going to stay pretty much constant at that point. Yeah, I really like that change. That really did a lot of good. So this is the hole. This is when it runs the compressor but has the bypass valve open, just in case that it has a very large load. And it's now going to reach the hysteresis point under the set temperature, and it's going to turn off the cooling. And it's going to keep the fan running for exactly 1 minute now. And once the fan has stopped, it is going to go in idle mode, but it is going to keep watching the case temperature. So almost there. So now it's turned off everything, and if the case temperature should rise over the case temperature threshold, it will turn on the fan and basically get rid of the stored energy in there, so it won't heat up the water. So that was my latest change, and I like it. So now for real, bye.